Hi Artie, I've got question 8 and 9 here on the screen. I'll just kind of set you up with how to do these. I won't do them for you, but I'll tell you what you need to do, okay? So for 8a, if you want the coordinates of the center of the circle, what they've done is they've given you the coordinates of the diameter. And if the center is right there, then all you need to do is find the midpoint, okay? So that should be an midpoint between the point 3,5 and 9,7, so the halfway point, okay? So pretend that this is an XY grid, and this point is at minus 3,5, and this point here is the 9,7, and use your midpoint formula to find the midpoint, okay? So that will give you the coordinates of the center of the circle. The radius of the circle, you can do it two ways for 8b. You can either find the length of the diameter by just doing the square root of the rise squared plus the run squared. And then what you could do is just take that and divide by 2 to get the radius. Or the other way you could do it is once you've got the coordinates for the center from part A, you could just find the length of that line segment from the center out to one of the endpoints and use the same formula that I've showed you here, okay? For number 9, determine whether the triangle with those vertices is isosceles. So we're going to draw our triangle on our grid, and we're going to label all of the sides. I don't think I did a very good job of drawing that triangle, did I? No, I didn't. Alright, let's start over. So draw your triangle on your grid. So point A is negative 3, 4, so there's point A. Point B is negative 1, negative 2, so there's point B. And point C is over 3 up 2, so there's C. So here's your triangle. And now we want to know if it's isosceles. So if it's isosceles, it means that 2 of the sides have to be equal. I'm just guessing that it might be AB and BC, judging by my diagram. They look like the 2 that might be the equal sides. But if you're lucky, if you find the length of AB and the length of BC, you might get that they're the same. And then you can go, therefore it's isosceles. If you're unlucky, then you'll also have to find the length of side AC to see if it's the same length as one of the other 2 sides. And as long as you have 2 sides the same length, then you have an isosceles triangle. So the length of AB, length of BC, length of AC, they're all following the same formula. Square root of, it's basically the square root of the rise squared plus the run squared. If you do that, and you're lucky for the first 2, you'll get 2 that match. And if you don't, you got to do the third one to see if you can get 2 lengths the same. So I hope that helps you with your ISU, and if not, we can always work at lunch tomorrow, okay?